students, we are going to see the learning objective of today's session. Design a threaded joint when eccentric load perpendicular to the axis of the bolt. This is case number 2. Then case number 3 is when load which is parallel to the axis of the bolt. Then case number 4 for a circular disc or how to join the circular planes to the bracket or the the all. That is case number 4. We will see all these different cases and how to design threaded joint for this particular cases. So today we are going to see design a threaded joint when eccentric load perpendicular to axis of the bolts. This is a learning objective of today's session, and we will focus today on this topic. And before that, the many parameters or many topics or small the fundamentals discussed by Professor V.K. Patil. What do you mean by left hand thread? What do you mean by right hand thread? Then different types of screws or set screws or the bolts. All aspects already covered by Professor V.K. Patil. But today is our main focus on design of threaded joint when eccentric load perpendicular to the axis of bolts. Now in this case, I would like to here look at this. Look at this. This is one of the, or you can say the bracket here, which is fitted here to this all. You can say the peaks 1, or you can say this is plate 1 or the plate 2, and this is the wall. How it is fitted? The only the important thing here is that today we are going to discuss this case. Eccentric load perpendicular to the axis of the bolt. Try to understand. And last time Professor Patil discussed the eccentric load condition when subjected to the load, and because of that, the force P and the fundamentals of eccentric load we studied in the static load design. Again, we are going to study the same fundamentals in welded joints also. How to attack such a the eccentric load problem. So what you have to do, always you have to shift the load at the center, and because of that it is going to act on the bolt, and along with this there is a couple which is going to act on it, and because of the load direct tensile the here shear stress or the shear force which is going to act on it, and because of that shear force primary shear stresses are going to induce in it, or you can say direct shear stresses. And then second, due to the couple secondary shear stresses are going to induce in it, and then you have to superimpose this primary shear stress and secondary shear stress to find out the resultant stress which is acting on the bolt joints, and by solving it you will get the cross sectional area of the bolt. From that, by referring the chart of IS or isometric series or the chart or table, you can easily find out which type of threaded joint or which is required for the particular application. These parts already covered by Professor V.K. Patil. Today we are going to see the eccentric load perpendicular to the axis of the bolt. Look at this now here. You will find here, these are the bolts here which are shown here, the bolt position. But now in this case, the last case, Professor Patil taken the 4 bolts 1, 2, 3, 4, and he is used the nomenclature P dash or P1, P double dash for primary and secondary shear stresses. Here also we are going to use the same nomenclature using in the VV Bandari's book, no problem. But you will find here at position 1 here, 2 bolts are used. At position 1, that's why and they are in the one line. Again, all these bolts are identical. That's why one it's okay. And another position is 2, total 4 bolts here. The bolts position 1. How many bolts? 2 bolts. And at position 2, again 2 bolts, total 4 bolts. Again, you will find the load P. You will find it's a front view or inside you will find here the load P. It is eccentric load acting at some distance for eccentricity. That's why here E. Right? But this load P, which is perpendicular, look at this point. This is the axis of the bolt, and this load is perpendicular to the axis of the bolt. That's why this is the second case. Eccentric load perpendicular to the axis of the bolt. Try to understand axis of the bolt. We are going to see today how to design such a component. So what is happening? The bracket or the 2 plates, or you can say the for different applications, different the brackets are used. Already these parts covered by But even though we will see some videos also that is prepared by Professor Patil, no problem. But today only your focus should be on eccentric load perpendicular to the axis. So look at this. This is eccentric load P. Bicentric, it is at a distance of P. That's bicentric. Then it is perpendicular to this axis of the boat. Try to understand. This is the case. And how to tackle such a situation? So because of this load, what is happening? This is one thing. And you know very well, this P is acting vertically downward. Because of that, direct shear force or direct shear stresses are going to induce in this one thing. And second is thing, P into E, it's a couple or a moment. When it is going to act, because of that, tensile stress which is going to induce in it. I will explain that. Whether it's a bending stress or the tensile and which type of stress which is going to induce in the bolt, we will see that. Second thing. And because of this load P, what is happening here, you will find there may be possibility of tilting of this bracket. Look at this, but where it is going to tilt, so you will find it the end edge, which is denoted by point C. At point C or the edge of this bracket here, you will find because of this load P, there may be possibility of tilting of this bracket. And you will find it is going to tilt at point C. And because of that, at position 2, bolt position 2, there is some deflection delta 2. Again, bolt position 1, there is some deflection, that is delta 1. This deflection situated on this edge point or the HC, it is at a distance of L1, and at position 2, it is at a distance of L2. And on the basis of that, we are going to carry out its analysis and we are going to tackle this problem. We will see. I hope you understood this figure of eccentric load perpendicular to axis of the bolt. Okay. Now let us see how to carry out this analysis. To carry out this analysis here, some assumptions are made. Some assumptions are made. So what are these assumptions? So like the first case also here, the first assumption is bracket and steel structure to which bracket is fitted by using the nut and bolt. They are rigid. Try to understand. Rigid. This is first assumption. Second assumption, the bolts are fitted in rimmed and ground holes. Why rimmed and ground holes? That means there is no any the interference in between the hole and the nut. That's why rimmed and ground holes. This is the second case. Then third one, bolts are not preloaded. Try to understand. Generally, you will find when you are going to tightening the bolt initially, when you are going to rotate in 1.5 turn, you will find the preloading of the bolt. But we are not going to consider or assume this case. Bolts are not preloaded. And second one, there are no tensile stresses due to initial tightening. This is the assumption. We are not going to take into account this tensile stresses due to initial tightening. That means no tensile stresses. This is third assumption. Fourth one, there is no stress concentration in thread, because if you are going to consider the isometric thread, the angle very well, it's a 60 degree. There are the edges creased and wrote, and because of that, generally you will find here the shape is not the sharp one. To avoid is the some the curvature which is given here. But even though threads are prepared on the shank or the bolts, you will find there is a stress concentration. But this stress concentration effect we are going to neglect in this case. This is the another assumption. And last important assumption, whatever the bolts we are using in eccentric load condition and different cases, that time we are assuming all bolts are identical. Very important assumptions. Otherwise what would happen? For each case, you have to go for the another different aspects. Look at this. There are at position 1, 2, 3, 4 bolts are there. All these 4 bolts are identical. We're trying to understand. Otherwise, their sizes are going to vary. That's why to carry out the analysis in simple way, we have to assume all bolts are identical. This is the last assumption in the analysis of this case. Okay. This is about the assumption, and based on this assumption, we are going to find out the
Sir, before this, one good example is present with me related to this case too. Can you share my screen as a presenter?
Okay. Oh,
Just
yes,
and
yes,
then
yes.
you can explain. It's a very good example for this case too.
Okay,
So
okay.
please make a presenter may
Okay, saving,
change the presentation.
change. Oh, yes, yes, yes. Vilas Patil, yes.
Okay.
You can, okay, you can do now.
Yeah, are you visible my screen?
Yes, yes.
The dear students is a very good examples for this case too, and the load is perpendicular to the axis of this board, and is our fire extinguishers setup is present in our institutes. Here is a drum, and this drum is basically useful for wound the hose pipe, either the pipe which is used for that fire extinguisher, and this total weight of this drum is acting on this frame, whatever the frame is present here, and this totally load is perpendicular to the axis of the load. See this, these are the four identical bolt is present here, and here one uh, four holes as well as this frame is connected with these walls. So it's a one good example here. Many example is present for this case too. So it's a one best example for this case. So okay, Kushara sir.
Okay, let us have your screen. I will discuss. Okay, no problem. Now, the whatever the case we are discussing today, you will find one, that means in at position one, 2 bolts, position two, 2 bolts. Then this distance you can say eccentricity E, and here the load which is coming or acting, which is perpendicular to the axis of the bolts. Try to understand. And now you will find such a, the many types of examples here. Okay, I will change the screen. Okay, show my screen. Okay, thank you, Patil sir. Now let us start the our the analysis, how to solve such a type of problem and find out the required board size. Now in first one you will find, as discussed earlier here, you will find in this case when it is subjected to P is the the force which is acting here directly. So what is happening because of this force P here, you will find it results in direct shear force, or I am going to say because of that direct shear stresses are going to induce. Try to understand. I have written direct shear force, but before that you have to find out the how much is the direct shear force in each bolt. Now again here the nomenclature which is used, P1 dash is the direct shear force at position 1. There are at position 1, or you can say 1 1, there are how many bolts? 2 bolts. Try to understand. And another one is the P2 dash is the direct shear force at position 2 2, and there are also how many bolts? 2 bolts. Try to understand. But because of this P which is acting perpendicular to the axis of bolt, because of this P, direct shear forces on the bolt, it induces or results in. And how to find out its magnitude? To find out its magnitude, we have to use simple expression. P1 dash is equal to P2 dash is equal to P upon total load here, load which is acting on the bolts upon number of bolts. Now in this case, 4 bolts. So you can write P divided by 4. So you will get P1 dash is equal to P2 dash. Now P1 dash means direct shear force at position 1 1, and P2 dash means direct shear force at position 2 2. And all bolts are identical. And even though if you would like to have a different nomenclature, at position bolt 1 2 3 4, you can give the nomenclature. At position 1, P1 dash. At position 1, bolt 2, you can use another nomenclature. At position 2, bolt 3. At position 2, bolt 4. No problem. So how to find out the direct shear force? Total load upon number of bolts. This is equation 1. Try to remember. Same very simple equation. And why we are dividing by the number of bolts here? Because all bolts are identical. We are making analysis simple. Then second case, here these are the bolts and the brackets subjected to load P, and this here is the eccentricity E. Because of this P, when it is acting, you can see it's a moment, that is P into E. Because of that, this bracket each tends to tilt. the bracket at about the edge. I have already explained these things. Once again, I will show where it is going to tilt. Look at this, the case. It is going to tilt here at position orient or location C. And because of that, this bracket is going to tilt. Try to understand. And here, couple plays important role. And to prevent this tilting, resisting force, or you can say resisting couple, which is going to act here. I will explain how to do these things while formatting some of the equation. You will get all the idea here related to this topic. So first of all, try to understand. So because of the force P, direct shear force gets resulted, and how to calculate it? That is P1 dash is equal to P2 dash is equal to P upon number of volts. Then second, because of the moment P into E, it tends to tilt the bracket at the edge C. But what would happen because of this moment? Each bolt is traced by amount delta. Try to understand. I have already shown to you, because this tilting at a position 1 1, that is delta 1, or at a position 2 2, delta 2, or L1 L2, that's nomenclature which is used, which is shown in figure, and which is proportional to its vertical distance from the point C, which is proportional to the vertical distance from the point C. Look at this here. I will once again I will show. It's the point or location. This location you can say 1 1 gets tilted by distance delta 1, and it's proportional to the distance from tilting edge. Tilting edge C. That means delta 1 is directly proportional to L1. And similarly here you will find this is position 2 here. At this position 2, delta 2 is directly proportional to L2. Try to understand. And this is going to happen because of the couple. I have already told you here. Now I have written these things here. That's why delta 1 is directly proportional L1 and delta 2 is directly proportional to L2. But we know that very well. Force is directly proportional to stress. So for that purpose, you can write this expression. Or stress is equal to force upon area. Therefore, force is directly proportional to stress. Then stress is strain. That means Hooke's law, within elastic limit, stress is directly proportional to strain. Epsilon is strain, and this and is the Young's modulus or modulus of elasticity. And then we know that strain and stress relation, epsilon is equal to change in length upon original length, that is delta upon L. If you are going to refer this, so you can substitute this epsilon here. So what you will get? Sigma is equal to what you will get? E into this epsilon means delta upon L. And again, you can substitute this E into delta upon L here again. So what you will get? The P is directly proportional to this delta. Try to understand. And that means P is also proportional to delta. And delta is proportional to L. Try to understand. That's why I have written these things here. Force is directly proportional to stress. You know very well. That is sigma. Stress is equal to force upon area. Then stress and strain, Hooke's law, and strain means stretch means change in length upon original length. Now, based on this, what we are going to say? This resisting force induced in any bolt due to this couple is proportional to its distance from the C. That means force is directly proportional to delta and L. And you know very well, L1 and L2 are the distance from the tilting edge C from the position 1 and from the position 2. That's why I have written the resisting force induced in any bolt due to couple or a moment is a proportional to its distance from the tilting edge C. And base, what is the reason? This is the reason. Mathematical analysis you can incorporate, you will get this mathematical, the equation. Based on that, we can say like this. Then next point. Again, based on that, you can remember delta is directly proportional to L1, delta is directly proportional to L2, but P is also proportional to now delta. Now try to understand based on this analysis, and I am going to write this. And because of that, if it's proportional to delta, that means it is proportional to length, because delta is proportional to length, L1 or L2. Now, therefore, if we are going to assume P1 dash double dash, because we have used the nomenclature P1 dash for direct shear force. Now here we are going to use another nomenclature P1 double dash. P1 double dash and P2 double dash are the resisting forces induced in the bolt, and these are resisting forces because of the moment P into U. Try to understand. And therefore, as per the the last slide logic, or the four relation between force and stress, stress and strain, strain and strain, based on that I am going to write P1 double dash is directly proportional to L1. Then P2 double dash is equal is directly proportional to L2. Why? Because P1 is directly proportional to delta 1 and delta 1 is proportional to L1. P2 double dash is equal to L2. Why? Because delta 2 is directly proportional to L2. We will get this expression. And again, we know that is directly proportional. We can use some constant of proportionality, and based on that, we can write P1 double dash is equal to C into L1. Similarly, P2 double dash is equal to C into L2, where C is the constant of proportionality or proportional constant. Try to understand. Now in this case, I have used only the P1 dash and P2 dash. Now we have considered only the four identical bolts. Look at this figure. Here one bolt, another second bolt is here at position 1, then another bolt here. This is the position 2. Then suppose I would like to add another 2 bolts here at position 3 here. Try to understand these 3. So what you will get here, the length is L1, here length is L2, and from this here you will get L3. Then you will get the resisting forces because of the couple here, P1 double dash. Here you will get P2 double dash, and here you will get P3 double dash. Try to understand. If I am going to add one more row of the bolt here, then you will get here you can say for third row, I am going to write P3 is directly proportional to L3. If I am going to add one more row here, so you can write P4 double dash is directly proportional to L4. Try to understand. Similarly, here also you can write P1 double dash is equal to CL1, P2 double dash is equal to CL2, P3 double dash is equal to CL3, P4 double dash is equal to CL4. Try to understand. So whatever may be the case, accordingly you can modify your expressions. Now here we have taken only 2 positions where 2 bolts at each position, total 4 bolts. We will carry out this analysis for the given the figure. Okay, no problem. This is about the P1 double dash is equal to CL1 and P2 double dash is equal to CL2. But because of this couple, what is happening? The resisting forces, I have already told, P1 double dash and P2 double dash are the resisting forces induced in the bolt. So what we have to do? We have to equate the moment due to these resisting forces with the moment due to external force P about the tilting edge C. About the tilting edge C. So what we are going to write? P into E. This is because of the force P, that is PE, and we have to equate with the moment due to resisting forces. Resisting forces means P1 double dash, P2 double dash. So here we are going to write P into E is equal to 2 into P1 double dash into L1 plus 2 into P2 double dash into L2. Why 2 here, which is used? So how many bolts? In one row, 2 bolts. Sorry, 2 volts. That's why 2 here it is multiplied by 2, because at position 1 in our case, the bracket at position 1 here 2 volts are used. That's why 2. Again here at position 2, again here 2 volts are used. That's why 2. Try to understand. Or you can take for 1 volt P1 double dash this L1 plus again P1 double dash into L1. You can add it. You will get 2 P1 double dash into L1. That's why you will get these values. And you can equate. After equating, what you will get? Again, but P1 double dash means what is the C into L1? And P2 double dash is equal to C into L2. So you can substitute these values here. The substitute here P1 double dash is equal to CL1. Here P2 double dash is equal to CL2. After substituting, you will get this expression here. What expression? P is equal to 2 into CL1 into L1 plus 2 in bracket CL2 into L2. Therefore, C is equal to, you can solve it, you can take C common, send all the terms towards the side. You will get P upon 2 in bracket L1 square plus L2 square, this C. Try to understand. And again, what you have to do? You have to substitute the value of C. What is C? P upon 2 in bracket L1 square plus L2 square. Here, so you can substitute the value of C. So what you will get? I am going to write. Suppose you can take this case. Now here P1 double dash is equal to, what is the C? This value P into E upon, or 2 in bracket L1 square plus L2 square. L2 square. And here into this I have substituted C, and into this L1. Look at this. After substituting these values, you will get this equation. P1 double dash is equal to P E into L1 upon 2 in bracket L1 square plus L2 square. Then similarly, you can substitute this C in another equation. So you will get P2 dash is equal to P into E into L2 upon 2 in bracket L1 square plus L2 square. But now again, this is for the two positions. Suppose, as discussed earlier, suppose there are three positions. This is one bolt, two bolts at each position, two. And again, I am going to write here bolt position three. Total how many bolts? 6 bolts. Here resisting forces P1 double dash at position 1, P2 double dash at position 2. Now here if third row is added here of the 2 bolts, P3 double dash. So what you will get the equation here? P3 double dash is equal to C into L3. And what you will get here? C is equal to, because we are going to add here 2 into, look at this, I am telling this about these three positions, total 6 bolts, P3 double dash into L3. So what you will get? Plus 2 times CL3 into L3. So what you will get? This expression. Again here you can add plus L3 square bracket complete. Try to understand. In this way, you can carry out this analysis. And if there is a fourth row again, total 8 bolts, so you can add it here plus L4 square, and here 2 remains same because 2. If there is a third bolt, like what I am telling now. Now 1, 2, 3 in one row, 3 at position 1, 3 bolts, then it becomes 3. Try to understand. Otherwise, this always 2. Only you have to add it. Accordingly, you can modify the formula. In examination, sometimes in one row 2 bolts, to position 1, 2, sometimes 3 bolts, or 3 rows, sometimes 2 bolts, 3 rows. Whatever may be the situation, accordingly you can modify this relation. Try to understand. This is very important thing. But here only 2 positions, 4 bolts. That's why you will get P1 dash is equal to this, and P2 dash is equal to this. Try to understand. Now you have a resisting forces P1 double dash, P2 double dash, and you have a direct shear force because of the load P. And I have already told how to calculate here. P1 dash is equal to P2 dash is equal to this P upon number of volts. Now come to these points. Important point. Give attention here. Now what is going to happen? Look at this diagram. You will find here at position 1, 2 volts, at position 2, 2 volts. And because of this force P, now here always, while finding out the bolt size, whether to consider the bolts located at position 2 or whether to consider the bolt located at position 1. In earlier case, eccentric load in voltage joints, explained or discussed by Professor V.K. Patil, you will find in direct secondary shear stress case, it's a resisting force again, resisting shear force. Earlier case, I am talking about the case explained by Professor V.K. Patil, secondary shear forces. During that time, you will find R1, R2, R3 they are the distances of the bolt position from the CG. And which bolt position is farthest position from the CG, where you will get the maximum force in bolt. The same approach we are going to use here, but the here the load which is perpendicular to the axis of the bolt, so you will find bolt which is located at the farthest distance, bolt which is located at the farthest distance from the tilting edge is subjected to maximum force. Now I will elaborate it. Look at this here, refer this diagram. Force P is acting, this is bolt position 1, bolt position 2, and because of this load, the bolt which is located farthest from the tilting edge is C. Which bolt is farthest from this tilting edge? The bolt position 2 or bolt located at position 2, they are not farthest. But bolt located at position 1, they are farthest from this tilting edge. So you can say bolt at location 1 are subjected to maximum force. Therefore, you can consider this bolt or this bolt, no problem to find out its size. Therefore, I hope you understand, to always consider the bolt which is located at farthest distance from the tilting edge, where you will get the maximum force. And based on that, the now in this case, from tilting edge C, the bolt position 1, they are farthest. So we have to consider this bolt or this bolt to find out the size. But we know that shear force act on the bolt because of the load P. We have already calculated in expression 1P upon number of bolts. This is the shear force. And how to find out the shear stress induced in it? By using simple elementary equation, tau is equal to force upon area. So you can substitute P1 dash upon area. Why I have taken P1 dash in this case? Because the bolt which is located farthest from the tilting edge C is P1 dash. So you can use P1 dash, you will get the tau shear stress. And A is the cross-sectional area of the bolt at minor or core diameter. Try to understand. Minor or core diameter. And another diameter is the outer diameter or the maximum diameter. Try to understand. So why I am telling here P1 dash is used, because it is farthest from the tilting edge, subjected to maximum. That's why take only P1 dash to find out the shear stress induced in the bolt because of the load P. I hope you understood these points, and this is the case. That means first of all find out this shear stress tau. Now you have the shear stress. Okay, now let us find the another stress which is induced because of the couple. Now I am going to show. Now here again the same fundamental you can use. The point which is located farthest from the tilting edge C. So again, which one is the this value that we have to take into account at the position 1. Therefore, second, the tensile force that's act on the bolt due to eccentric load perpendicular to the axis, where we get the maximum at position 1, which is the farthest from the tilting edge. Therefore, again consider P1 double dash is equal to P into L1 upon 2 in bracket L1 square plus L2 square. And this is for 2. And again here, the position 1 that we have to consider. Therefore, find out tensile stress in the bolt. Try to understand. So therefore, I am going to consider P1 double dash upon A. A is the cross-sectional area I have told at the minor or core diameter of the bolt. So you can use this equation. Now, from first equation, you will get tau. Second equation, you will get sigma T, tensile stress. Now, you have two stresses because of direct load P, shear stress tau, and because of the moment, you have sigma T, tensile stress. And again, which bolts I have considered? So we have considered the bolts at position 1, which is farthest from the tilting edge C. Don't take the P2 double dash. Okay, now we have tau and this. So if the bolts are subjected to shear and the tensile load, so you know very well, such in these cases, bolts are designed on the basis of, there are 5 theories, but we are going to use 2 important theories here. principal stress theory, this is one, and second one is the principal shear stress theory, second one. Again, sometimes in examination, they are going to ask use principal stress theory and find out the size of the bolt. Sometimes they may be ask you to use principal shear stress theory. Whatever may be the statement, you can read it carefully and solve the problem accordingly. So by using the principal stress theory, you know very well what is the expression for principal stress. Sigma 1 is equal to sigma t by 2 plus under root sigma t by 2 bracket square plus tau square. Here you can substitute sigma t, which is calculated from this expression, and tau from which expression that you are going to use. Tau, I am going to show here. I would like to zero. Tau is equal to P1 dash by A. You will get tau here. So from this direct shear, you have to use direct shear stress. You can substitute tau sigma t from this expression from the couple or the tensile stress. You can substitute. You will get sigma 1. Sigma 1 is the principal stress, but you have to equate this sigma 1 is equal to SYT upon FOS. SYT means yield tensile strength of the material used for the bolt. So you can use here and compare it. You will get here the cross-sectional area here, because in sigma t it is in terms of area. So you can find out this area, and again area you know very well, pi by 4 into minor diameter or the core diameter of the bolt. Find out core diameter and then nominal. You know very well how to find out. There is a relation of D and DC in terms of 0.8, already discussed by Professor V.K. Patil sir. This is about the principal stress theory. And another theory is principal shear stress theory. According to this theory, you know very well the expression tau max is equal to sigma t by 2 under root sigma t by 2 bracket square plus tau square. You can substitute tau here and sigma t here, which is calculated from here P upon number of bolts. You will get tau, that is shear force, and then shear force means load upon again area. Similarly, sigma t you have calculated from the couple, that is tensile stress. You will get tau max. Again, if this tau max in terms of area, and how to substitute the value of tau max? SSY upon FOS, and you know very well SSY is equal to 0.5 SYT upon FOS. Try to understand. So you can write here 0.5 SYT upon FOS is equal to this term, and where sigma t and tau in terms of what area? Cross-sectional area. Again, from this cross-sectional area, you will get the minor diameter or core diameter of the bolt. Try to understand. And again, you can easily find out, you can refer the charts given by for isometric threads to find out the size of the bolts. You can easily find out. Okay, this is about the today's second case, when eccentric or bolt subjected to eccentric load which is perpendicular to the axis of the bolt. But I have told you there are two the theories that we are going to use. One is the principal stress theory and second one is the principal shear stress theory. But suppose I have written here, so you know very well generally bolts are made of ductile material, and you know very well for a ductile material which theory is appropriate? The principal shear stress theory is appropriate. If it is not mentioned in problem statement or while selecting or deciding the bolt size, that time if it is not mentioned in the statement, that time always you have to prefer principal shear stress theory. Why? Bolts are made up of ductile material. Try to understand. Bolts are made up of ductile material, but in examination sometimes they may mention use principal stress theory. That time you can use the theory which is discussed here, sigma t by 2 plus under root sigma t by 2 bracket square plus tau square. Try to understand. I hope you understood these things. This is about the today's session. Thank you very much. I have referred VV Bhandari's book for this case. If you have any query, please contact us through the WhatsApp number or mail us. My mail ID pbkushare@kkwac.edu.in. Thank you. This is about today's session.